you by the Rogers Corporation. Today's topic, Power Amplifiers Part 1, High-Frequency Materials for use in millimeter wave small cell equipment.
Hello and welcome. I'm Aguayo from Rogers Corporation. I'm here to talk to you about 5G and the development of this technology and the way in which Rogers Corporation, with its 50 years of knowledge in material technology, is prepared to meet your designer needs as we approach the new challenges of 5G. In this presentation, we will discuss where in the 5G network we'll see the need for high-performance materials and power amplifiers. We will discuss various material solutions at frequencies below 6 GHz and in millimeter frequencies. We will also provide some detail on electrical performance in this frequency range. I've listed high power solutions and thermal management in this agenda. It actually is a teaser for part 2 of the power amplifier videos to encourage you to continue watching. From what we know about 5G is that it will be an immersive network, a network that provides data at rates whenever we need it, how fast we need it, wherever we are. To do so will require new technology and new materials to achieve that technology. To do so, infrastructure needed will be throughout the city, indoor and outdoors. Super dense structures like concert halls and sports stadiums. Some applications will rely on very high levels of reliability, like remote surgery and autonomous vehicles. Personalized broadcasting that we're beginning to see now in some social media applications will continue to increase in users and in events, while the number of devices joining the IoT, or Internet of Things, continues to grow. As these networks become more part of our day-to-day activities, focus on reliability connectivity will be a must. Rogers' extensive product portfolio of high-frequency materials will give designers many options as amplifiers and other parts of the network are being developed. When we link network capability with network application uses, we map a series of requirements that can be viewed as 3 different networks working together. We will see 5G roll out in waves. We're beginning to see the first wave. That is the area of multi-gigabit fixed wireless data services to homes in North America. This is a special case of enhanced mobile broadband, as it actually is not a mobile and carrier-to-carrier network compatibility is not a must. We have seen cooperation at this year's Mobile World Congress, where many of the OEMs are moving in a direction to speed up this technology so as the deployments can be quicker. Amplifiers at various power levels will be needed throughout, and the needs for the materials are varied. Rogers is in a position to provide these materials as the designers are needed to move forward in the new technology. Rogers has developed materials to meet the technology of telecommunications since the 1990s. It all started with materials like the RO3000, PTFE ceramic materials, moving on to the RO4000, the first generation of thermoset woven glass materials to meet the needs of 2G and continue the evolution. Rogers developed this material to revolutionize the industry and bring about cost-effective multi-layer RF technology, something that was needed in order to meet the 2G and emerging 3G and eventually 4G needs. Since the early 2000s, Rogers has continued to develop unique material solutions that match material property benefits to circuit performance needs. Higher degrees of integration was needed, and the industry transitioned to 2G, and once we arrived to 4G, we began to see the initial development of the technology ultimately called 5G. Higher data rates and higher frequencies, along with adoption of active antenna systems in 4G, has led to massive MIMO technology, a miniaturization of components for 5G. At Rogers, we continue to focus on the materials that can help drive the next generation of 5G. High-performance materials can be divided into 2 subsets. We have thermoset materials that focus more on cost, while we have PTFE materials that focus more on performance. Which material to use depends on the application and the goals of the designer as to what kind of performance cost value they need to achieve. Our 4000 family of products consists of thermoset ceramic-filled woven glass materials that have loss in the area of 003 to high 003s depending on 2.5 or 10 gigahertz, and dielectric constants of 3.5 to 6.15. In combination with the RO4000 prepregs, these materials offer very cost-effective manner in which to build multi-layer boards. These products are most used in wireless infrastructure base station power amplifiers. RO3000 materials are mainly PTFE and ceramic, non-woven glass. The advantage of these products is that they offer the lowest loss solution when it comes to circuit losses. 1/2 to 1/3 of the loss tension compared to RO4000 products. Designers needing them to maximize the benefits of low loss will select these products. Although all these products are listed here can be considered high thermal conductivity materials in the industry, the TC family is one step above. These products are the highest in the industry for commercial applications. Designs where thermal management is critical will often rely on these products. More detail will be provided in Part 2 on Power Amplifier video series for high thermal management. In the millimeter wave spectrum, losses are very important to control. Materials with low dielectric constant are often desired because they maximize the width of the traces and lower the circuit losses. But R4000 materials or thermoset materials can also be used depending on the frequency range if you're operating at 20, 30, maybe up to 40 gigahertz. Beyond that, PTFE materials are often favorable because of lower losses, lower dielectric constant values. So we have a series of products to offer. In addition, sometimes you'll have thin dielectrics, ultra-thin dielectrics, 1, 2, 4 mils, that are desired for certain applications in this frequency space. And Rogers has material options to meet these needs. The first class of high-frequency PCB materials introduced in the market combine PTFE resin with glass, RT George 5880, non-woven glass, and Diclad 880 with woven glass. These materials are mainly PTFE with dielectric constants of 2.1. Electrically, these materials often offer the lowest loss solution and tightest decay tolerance. However, these materials do have high PTFE content and have high Z-axis expansion coefficients and are often not recommended for multi-layer constructions. In the mid-range of PTFE materials, we have the RO3003 and CLT products. They use ceramic and have woven glass in some case. PTFE mechanically and electrically balances with those resin systems. These materials have excellent plated through-hole reliability, and their coefficient of expansions are matched to copper, allowing for excellent multi-layer capability. The thermoset materials with mid-decay, they do not use PTFE. Instead, they use the resin with thermoset resin with ceramic filler and with woven glass materials. The advantages of the RO4350B and 4835, as well as the 4730G3, are mainly that they are the most economical material pricing, to be the lowest among the high-frequency materials in addition to conversion costs, lower than PTFE. These materials have been used up to 40 gigahertz in microwave backhaul radios and with the use of low-pro technology copper. Unique to this family is the RO4730G3 material, as it has a decay of 3, like RO3003 laminates, but it still has the advantage of low-cost processing. In the LCP category, UltraLamp 3850HT is a liquid crystalline polymer film, the only one in the group that is pure resin. The advantage of this material is that it is available in thinner and it's a low-loss material, available in 1, 2, and 4 mil thicknesses. Most other materials in this table do not have options below 100 micron, 4 mil. It is a thermoplastic resin, so special processing is needed when trying to build a multi-layer construction. We've talked much about properties and materials, decay, DF, CT, Z-axis, thermal conductivity. But all these things really are very hard to compare, are very hard to mean something until we put it in perspective on what it means to the designer. So to the designer, what's important is to minimize conductor losses, to minimize insertion loss, and to compare various materials against each other to see and weigh the benefits of performance and cost on the way we look at insertion loss. When it comes to the lowest insertion loss with these 10 mil materials, we can observe that RO3003 rolled copper measures less than 0.4 dB per inch. That is the orange line. Comparing the same material but the effect of increased copper roughness on insertion loss, the blue line shows again the RO3003, but this time with ED copper, electrodeposited copper, 0.6 dB at 40 gigahertz. That is 50% more loss than rolled copper option for the same material. The first RO4000 material, RO4730G3, the gray line, with a decay of 3.0 and using smooth copper, low-pro copper, measures at slightly above 0.8 dB per inch, while RO4350B, which is the same as the RO4835 material, is slightly under 1 dB per loss. All these materials are with copper only, no plating. The graph gives designers great insight into performance trade-offs, as one selects the best price to performance option. In this case, rolled copper RO3003 would be the highest cost, while the RO4350B or 4835 Low Pro would be the lowest. In conclusion, Rogers has a rich history of supporting the wireless infrastructure market for over 20 years. The vast selection of materials, PTFE-based and thermoset resin, give designers a multitude of options when designing amplifiers and radios for millimeter wave frequencies to be used in 5G infrastructure. Rogers' in-depth understanding of material characterization in the millimeter wave bands gives Rogers keen insight in developing the next generation of materials to be used in 5G. This concludes this segment of our Road to 5G video. Thank you for watching.
For additional information and technical tools, if you're not already a member, join the Rogers Technical Support Hub and gain access to calculators, technical papers, and more Rogers Corporation informational videos. Rogers Technical Information is also available at your fingertips with the Rog mobile app, available for the iPhone, iPad, and Android devices. Check it out today.